Good day, everyone. Welcome to Conversion of Units. This is still part of the introductory lectures on Physics 1. So we are actually done with the introduction of the basic quantities and derived quantities. So next step in our lecture is the conversion of units. Okay, so before we proceed with the actual conversion of units, let me introduce again the some of the quantities that we're going to make use in our conversion. Okay, so in order to properly convert any quantity that is expressed in one given unit and we want to express that number in a different set of units, we need to first recall that there is a conversion factor between these units. So each of the basic quantities and even the derived quantities has this conversion factor that we make use in order to convert properly one quantity that is expressed in one set of units and that we want to express it on a different set of units. So let's start with mass. What you see here is that you have a set of units in this column. These are the set of units that we usually encounter or we commonly use or people commonly use for expressing the quantity mass. So we have here the micrograms, milligrams, grams, kilograms, the pound, the ounces or ounce, grain, ton, stone, carat, and so on. Now, these common units, among the common units, the International System of Units standard for the unit of mass is the unit kilogram. Now, the pound is the standard for the British System of Units, but scientifically used units, we make use of the International System of Units, so we make use of mass. Okay, so these are the symbols for the corresponding units. We have the microgram has this symbol. The this Greek letter is called the mu, or this is read as the micro. So we attach the small letter g to symbolize the gram. So this is read as microgram. Okay, so we have milligrams, grams, kilograms. We have the pound. The symbol for the pound is the LB or the LBS. LB stands for Libras. If you're familiar with the zodiac sign of the Libra, the zodiac sign of the Libra has this symbol for the scale. Okay, so the scale represents, of course, the weighing of masses. So the Latin word Libra was used to represent the symbol for the pound, since the idea is that masses, you need to weigh the masses. Okay, so ounces, you have grain, ton, stone, and carat. Okay, so what you see in this table are the conversion factors for the corresponding um, conversion in between these system of units. So for example, from our standard of units, we'll have the kilogram in this row and in this column. This would be the intersection of kilogram and kilogram. Of course, if the unit here is 1 kilogram, this column here represents 1 unit of the given unit, one quantity of the given unit. So for example, here kilogram, this means this is 1 kilogram. Okay, so 1 kilogram, convert that to this column for kilograms. Of course, 1:1, so you have 1. Now, if you're going to express the one quantity of the kilogram in a different set of units, for example, 1 gram, in terms of grams, what we need to specify is the amount of the conversion factor between kilograms and grams. So, in the International System of Units, we make use of prefixes in order to express degrees of magnitude. So, in the prefix kilo, kilo represents 1,000. So, 1,000 of a gram, that means for every 1 kilogram, you have 1,000 grams, just like what we see here in this conversion factor. Um, Next, perhaps we want to convert kilograms to milligrams. So milligrams is 100 or 1 millionth of of a kilogram. So the conversion between 1 kilogram to milligrams is you have 1 million milligrams for every 1 kilogram, and so on. Now there are many conversion factors that you can see here in the table, but some of which are most commonly used. For example, between the English system and the SI system, between converting kilograms to pounds and vice versa, we usually make use of this conversion factor that for every 1 kilogram there is actually 2.2 pounds here. So these are commonly used conversion factors that we usually encounter both in scientific experiments and uh, industrial use or common use. Now, of course, there is a lot of quantity or conversion factor in each of the given table. For example, here is just an example. If you're going to look at other basic quantities such as length, you can see an array of many conversion factors, many common units. The idea here, since there is a relatively big amount of information, that means it would be impractical for us to memorize each of the conversion factor. But it would be impractical also for you. For example, if you're going to take the exams for an exam wherein you are asked to convert one system of unit to the other, it would be impractical for you to memorize the conversion factors for every given combination of the quantity expressed in one unit and its conversion factor to another unit. Now, the idea here is simply to memorize a few of the conversion factors so that you could work out the conversions yourself. So that means in order for you to properly convert one quantity in expressed in one unit to to the same quantity but expressed in a different unit, you need to specify how many steps that you want in order to convert properly from one system of unit to the other. You need to specify a finite number of steps, given that there are a few of them that you actually memorize. During the exams, you're not actually allowed to have a copy of all the conversion factors. But of course, if you have your scientific calculators with you, some features of some scientific calculators, they have these conversion factors that you could look within its function. So given that, then you will not be having any problems. But of course, if you do not have, or the proctor of the exams does not allow you to bring your own calculators, then you will be having this difficulty of looking for the conversion factor. So what I suggest is that we make use of the common conversion factors that we know. So for example, commonly used conversion factors such as pounds to kilograms. For every 1 kilogram, you have 2.2 pounds. Those examples that are common, we can make use of those examples so that we can properly convert, making use of common units. Let me illustrate that using the idea of length or the quantity length. Common examples for that we usually use in common conversions are the units foot, mile, yard, inch, meter, centimeter, kilometer. So among these are there are common easily memorized conversion factors that we can make use in order to perform properly conversion factors, especially during exams wherein perhaps we will be asked to answer common conversion factors for common examples. Okay, so let me illustrate that. So we have, for example, foot to inches. So we know that for every 1 foot, let's look for the conversion factor of inches. So we have here this one. Of course, the idea is for every 1 foot, you have 12 inches. 12 inches. So this is one of the common examples of conversion factors that we normally make use of in common usage. Okay, so let me illustrate another example. So we have the yard. So for every 1 yard, you actually have 3 feet. So as you can see here in the conversion factor between the yard and the feet. So for every 1 yard, you have 3 feet. Remember that this column here represents 1 unit of the basic quantity. So we have here the yard. So for every 1 yard, you have 3 feet conversion. Okay, so for obviously, if we're going to convert 3 feet into the number of inches, you just multiply it by 12. So you will have 36 inches for every 1 yard. Since there is 12 inches, or there are 12 inches for every feet, and since 1 yard you have 3 feet, you just multiply 3 with 12, you will have 36 inches for every 1 yard. Okay, so um, let me point out another common example. This example is easily memorized. Okay, so the conversion between uh, take note that this conversion factor is a key point in conversion. The this We can actually make use of this conversion factor so that we could connect the set of units for the British system to the set of units for the international system of units, particularly this conversion between inches and centimeters. Okay, so here is the conversion factor. So for every 1 unit of the inches units, so for every 1 inch you have 2.54 centimeters. And this is an exact value. So that means if you're given, for example, the number of foot, and we want to convert it into the number of meters, we could probably make use a four-step conversion. So from we convert foot into inches, inches to centimeters, and then centimeters to meters. So the connection between converting inches to centimeters serves as the common conversion between the set of the British system of units for length, connecting it with the set of international system of units, or the metric units. Okay, so let me finish through. Let me go through with the set of units that are presented here. So already presented to you the sets for a set of units for mass. Okay, so next is length. Okay, so what you see here in the column for length is that, as we know, in the international system of units, we make use of prefixes in order to specify the degrees of magnitude for a given quantity, which represents powers of 10. Okay, so what you see in the table are just the common conversions, common prefixes, and the corresponding number of magnitudes or powers of 10. Okay, so starting with the base unit meters. Okay, so meters to meters is of course 1. Centimeters is actually 100 of a meter. So for every 1 meter, we expect that we have 100 centimeters, just like what you see here, see here in the table. Okay, so next is millimeters. So millimeters, for every 1,000 millimeters, you have 1 meter. So that means for every 1 meter, if you're going to divide 1 meter by 1,000 units, then for every unit you have 1 millimeter. Okay, so kilometer naman. Kilometer is kilo represents 1,000. So a factor of 1,000. If you're going to multiply the base unit meters by 1,000, you will have 1,000 meters. That represents 1 kilometer. Okay, so these are just common units for length. Uh, there are there appears here in the table for length some of the units for length that we usually make use in industries such as nautical mile. The nautical mile is actually used for measuring distances in the sea. So of course, in terms of distances, you do not have actually a ruler for that you can draw on the surface of the water. So the idea is in terms of this measuring devices that can make use of measurements in terms of the distances that we usually use in those instruments such as the radar or for example in telescopes or the sextant. So if you are familiar with those types of instruments. Okay, so another curious unit for length as appearing here in the table is the light year. The light year is actually a measure of distance or length. It's not a measure of time. It is a common mistake that when we hear the word year from the term light year, we usually mistake it as a measure of time, but it's not actually a measure of time, but the light year is actually a measure of length. It is actually the measure of the distance traveled by light in 1 year. So how much distance is covered by light in a given time in a year, that is called the light year. In terms of kilometers, the number of kilometers for 1 light year is this one, 9.46 to the positive 12. That means you have 946 followed by 10 zeros. That's the number of kilometers that light travels in a given year. Okay, so let's have the units for time. Okay, so again, as you what you see on the board are the common units for time. We have the millisecond, we have the second. The second, by the way, is the standard of units for time for both the International System of Units or the metric units and the English or the British System of Units. Okay, so we have the millisecond, the second, the minute, the hour, day, week, month, and year. Of course, since we are more commonly familiar with the set of units for time, I expect that this would be easily memorized. So, for example, for the conversion between day and hours, of course, for every 1 day we have 24 hours. For every 1 week we have 7 days. We have for every 1 month you have 30 to 31 days. But on the average, the number of days if we're going to convert and making use of the conversion of the number of hours and the number of days, 1 month is on the average is 30.41667 or 30.4 plus 2/3 of a day or the number of days for every month. Okay, so doing the same for the number of days in a year, we make use of commonly use the number of days for a year as a conversion factor, the value 365.25. But if we're going to make use of the usual number of days as 7 days, 7 days and the number of days in a month, converting it into the properly on the number of years, so we should arrive with this conversion factor 365.046 number of days for every given year. Okay, so and so on. Okay, so what I have presented to you is the set of units for mass, the set of units for length, and the set of units for time. These units mass, these quantities mass, length, and time, these quantities are considered in physics as basic quantities. They are basic quantities. It is because the quantity is actually measured directly. They do not come from definitions or derivations, but in order to define the conversion factors, you need to directly measure the amounts, such as if you want to measure the number of days for time duration, you need to actually measure it using a clock. For length, in order to measure the given distance, you make use of a ruler. For mass, in order to directly measure a given mass, you need to have a weighing scale to do that. But there are actually quantities in physics that we make use in terms of derivations, and we call them derived quantities. So example of derived quantities as presented here in the module is speed, area, and volume. Okay, so speed is defined as the ratio between the amount of distance covered by an object divided by the time it takes to cover such distance. So that means the speed of an object, how fast the object is moving, is actually a measure of two quantities, which is combined together in order to form the quantity speed. Particularly, in order to measure speed, you need to measure the length, meaning the amount of distance covered by the object, divided by time, or the time it takes to cover that distance. So dividing distance over time or length over time gives you the quantity speed. Therefore, speed is not a basic quantity but a derived quantity. The same goes with area. Area is actually a measure of the flat space of a plane. So in order to measure the how much space is covered within a plane, what we do is that we multiply one side of a given plane. For example, our plane is actually a rectangle. So what we need to do in order to measure the area of a rectangle is that we multiply the distance of each of the sides. So for example, the length and the width, you multiply the length with width, therefore making area a derived quantity, not a basic quantity. The same goes with volume. The difference between area and volume is that volume is considered as the amount of space in 3D, meaning three-dimensional measure, whereas the area is actually a measure of space, but in a two-dimensional measure. So length times width. Therefore, volume, in order to measure the amount of space for volume, you multiply the three dimensions, or the three given dimensions of length, width, and height. Okay, so making volume a derived quantity, not a basic quantity. Okay, so we're done with differentiating basic quantities with derived quantities. We're also done with the set of units, common units for the basic quantities: mass, length, and time. So perhaps we could proceed with the common units used for the examples for the derived quantities, what that you see on the screen. Okay, so let us have first the speed. Okay, so the standard for measuring length is the meter. The standard for measuring time is the second. Therefore, the standard for measuring speed is actually meter per second. Now, common units that we make use in specifying speed are the following: miles per hour, kilometers per minute. So these are the common units that we usually express speed. Okay, so there are also units that appear here in the table that are that we make use of. We make use in this industrial purposes, such as the nautical mile per hour, and the Mach. The unit Mach is the unit for speed that we usually associate with measuring the speed of sound. So for example, when we say the speed of sound is Mach 1, that means the sound is actually traveling at 300 kilometers per hour. So that is Mach 1. Uh, if you're familiar with the speed of airplanes, wherein some of the planes are said to be supersonic, that means that the speed of those planes exceeds the speed of sound. So for example, a particular jet plane travels at Mach 2. uh, the actual speed is actually twice the speed of sound. So that means the airplane at supersonic speeds actually breaks the sound barrier, especially when its speed is specified in Machs that are greater than 1. So Mach 2, Mach 3, and so on. The knot here, as you see on the screen, is actually the a measure of the speed of water vehicles, especially jet boats or crew high-speed cruises. So submarines. So when we specify how much how fast these vehicles are moving, so we usually hear it as in terms of knots. So for example, they are moving in 40 knots and so on. Okay, so common units for area. Common units of area that we usually encounter in industrial purposes or common usage. We have the following: we have square miles, square meters, square kilometers, the acre, the hectare, and so on. Common units for volume. We have the cubic millimeters, cubic centimeters, cubic meters, cubic foot, the liters, the milliliters, gallon, the quarts, the pints, and the ounces. Okay, so we are now ready for the conversion factors or the conversion of units. Okay, so the idea for the conversion of units is that for every given quantity that is expressed in one set of units, there are times that we want to convert the number of units into a different set, such as, for example, when we are measuring heights or depths. For example, for basketball players, sometimes that we see on the presentation in the height of a person. For example, if in medical documents, we usually see the height of a person expressed in different set of units. So it is worth knowing how do we convert one set of units to another. So for example, the height of a person, usually we express it in terms of the number of feet, and normally we also want to know how much would that quantity be in terms of the number of centimeters. So for example, the height of a person is 5 feet 6 inches. It is worth knowing that how much is 5 feet 6 inches in the number of centimeters. Okay, so perhaps we could try that. We want to convert length, convert, for example, 5 feet, so into the number of feet, number of foot, foot for singular, feet for plural, and we want to convert this into the number of centimeters. Okay, so probably we could there is a technique in the conversion factor wherein you need to specify the number of steps in order to perform the conversion. So you could actually have a single step conversion for converting the number of feet to the directly to the number of centimeters, if for the condition that you know the direct conversion between foot and centimeters. So for example, if we do know the conversion factors, such as we know that for every 1 foot there is 30.48 centimeters, then we could actually directly convert 5 feet to the number of centimeters simply by multiplying 5 with the conversion factor between feet and centimeters. So 5 times 30.48, that gives you 152.4 centimeters. But of course, 30.48 centimeters is not a value that is easily memorized. Just like what I have given you a while ago, or presented to you a while ago, that in order to convert one set of units, you need to at least memorize the conversion factors, the common conversion factors. Primarily because you cannot actually memorize everything, since there is a large volume of data that you need that we have as a set of conversion factors. So the most practical approach to conversion is to remember the most common among them. So for example, just like what I have presented to you, that the connecting value between the metric system and the British system is the conversion between the number of inches to the number of centimeters. So for every 1 inch, you have 2.54 centimeters. So in order to convert the number of feet, 5 feet, into the number of centimeters, perhaps we could employ a two-step solution. So instead of one. So for example, making use of a two-step solution, converting feet to inches and converting to inches to the number of centimeters, just like what you see on this module. So what we have done is that we make use of a two-step conversion, converting the number of feet to the number of inches first, then converting the inches to the number of centimeters, making use of the direct conversion between inches and centimeters, that for every 1 inch you have 2.54 centimeters. So of course, you will be left with the conversion. In order to convert 5 feet to the number of centimeters, you need to multiply 5 by 12 by 2.54 divided by 1. Okay, so having said that, let's now proceed with the technique of the conversion. Okay, so the idea of the conversion is that if you're given a quantity expressed in one of the units, for example, foot, the idea here, in order to convert foot into the number of centimeters, is that you need to cancel out the unit foot, leaving out the target unit centimeters. So in order to do that, you need to multiply 5 feet by the conversion between foot and inches, specifying that the foot should be in the denominator, or should appear in the denominator, in order to cancel out foot. Otherwise, if you're going to have the conversion for foot in the numerator, you will not be able to cancel out the unit foot here. So that means the basic idea for the technique of conversion is that for the given unit expressed in one unit, in order to cancel that out, you need to provide the conversion factor in the denominator in order to cancel. Okay, so just like what appears here, that in order to convert foot into the number of inches, the unit foot should appear in the denominator. Okay, so take note. Between the unit inches and the unit foot, inches is actually the lesser measure between inches and foot. So inches and foot. So that means between inches and foot, inches is actually lesser in terms of measure, as compared to the measure of the foot. That means in your solution, there should be a greater number of inches as compared to the number of foot. That is why you have 12 units of inches for every 1 foot, since the idea is that the inches is a lesser or a smaller measure of length as compared to foot. That means there are more inches within a foot, as there are foot in inches. But if you're going to have this in reverse, if you're going to specify 1 inch, there should be a lesser number of foot as compared to 1 inch. Just like what happened here, when I reverse the direction of the inequality, the number of foot becomes a lesser value as compared to the number of inches. But actually, regardless of whether you're going to make use of this conversion factor, 1 over 0.0833 and so on, for 1 inch, for for every foot for within 1 inch, still you will be arriving with the same number of centimeters when we do the conversion factor. Okay, so let me repeat that. Let me go back to the inequality that the unit inches is actually lesser than the number of foot. Okay, so making use of 12 inches per 1 foot, you see that the answer is 152.4 centimeters. But if you're going to reverse it, you still have the same answer, even though you make use of a different set of conversion between 1 inch and the number of foot. But of course, between memorizing or remembering 12 inches for every 1 foot, compare that to remembering 1 inch for every 0.0833 and so on number of feet. Of course, it is easier to remember that there are 12 inches in 1 foot. So preferably, we actually prefer to make use of a conversion, making use of familiar units rather than memorizing or remembering the set of units that are too complicated to memorize. So, as a suggestion, just like what I have mentioned, is that we make use of the set of conversion factors that are easily memorized, such as the number of inches, the number of feet, 12 inches for every 1 foot, 2.54 centimeters for every 1 inch. Okay, so let's make use of a different set or different examples. So, for example, we make use of say 32. We want to convert this into the number of miles. This is expressed in miles. We want to convert this into the number of kilometers. Okay, so again, the technique in converting a set of units is to determine how many common units that we actually memorize in order to perform indicate the number of steps in order to arrive with a conversion. For example, the conversion of miles to kilometers. So okay, so first, since I am the one who is presenting the example, I will be the one who will be specifying the number of steps. So, for example, I'll be doing this in converting first miles to feet. That's one step. Feet to the number of inches. So that's step number two. Next is converting the number of inches to the number of centimeters. So that is 3 steps already. Okay, so next is converting the number of centimeters to meters, and then finally converting meters to kilometers. So I have employed actually 5 conversion steps. So if I'm going to specify here 5 conversion steps in order to convert the number of miles to the number of kilometers. Okay, so let me first set the details. So what I'm going to do is to convert miles to the number of kilometers. So converting first in my first step, converting miles to the number of feet. Okay, so what you see here is that for every 1 mile, you have a very an exact value for the number of feet. You have 5,280 feet. Okay, next is converting the number of feet to the number of inches. Okay, so just like what I have presented to you, the number of 12 inches, there are 12 inches for every 1 foot. Okay, next is converting the number of inches to the number of centimeters. Okay, so for every 2.54 centimeters, you have 1 inch. Next is converting the number of centimeters to the number of meters. Okay, so for every 100 centimeters, you have 1 meter. Then finally, converting meters to kilometers. Okay, so of course, for every 1 kilometer, you have 1,000 meters. Okay, so let us check first the notes here of the degree measure between the corresponding set of units. For example, between feet and miles, feet is actually the smaller measure as compared to miles. So feet is lesser than miles. Therefore, we expect that we have a greater number of feet as compared to miles. So just like what we see here in the conversion, there are more feet in a mile than there are miles in 1 foot. There are 5,280 feet in 1 mile. Okay, next, between inches and feet, inches is the lesser measure between inches and feet. So we expect that there are more inches in 1 foot than there are foot in 1 inch. Okay, between centimeters and inches, of course, centimeters is the lesser measure between as compared to inches. So we expect there are more centimeters in 1 inch than there are inches in 1 centimeters. Okay, so between meters and centimeters, meters is the greater measure as compared to centimeters, so we expect that there are lesser meters in centimeters, there are more centimeters in a meter. So you have 100 centimeters in 1 meter. Then finally, we have kilometers and meters. There are the kilometer is the greater measure as compared to meter. So we expect that there are more meters in a kilometer than there are kilometers in a meter. Okay, so finally, the last step in the conversion is to multiply the conversion factors to the given. So you have 32 miles multiplied by 5,280 feet multiplied by 12 inches. Multiply that with 2.54 centimeters divided by 100 divided by 1,000. Here, what you see in the solution is that I did not include in the multiplication by one, since of course obviously multiplication by one gives you the same number. Okay, so I expect that you will be doing the conversion on your own in your own scientific calculator, so that you could verify the answers on your own. Okay, so the highlighted cells in yellow is actually the final answer. So that means for every 32 miles, you have 51.499,008 kilometers, or about 51.5 kilometers. Okay, so what I have presented to you as an example is a relatively easy example, because it is simply a conversion of quantity expressed in one particular unit, and we wanted to express that into a different set of units. But of course, the quantity length is a basic quantity. Now, what if we are given actually a derived quantity instead of a basic quantity? So for example, the quantity speed. So for example, we have 60. Let's have this in terms of miles per hour. And we want to convert the given 60 miles per hour into the number of, say, meter per second. Okay, so I wanted to employ a 5-step solution for this one, so that we can have this as our solution.